Okay, this explanation is for those of you that have chosen to do a chi-square test of association. What you should have already completed is you should have looked at how you were going to collect the sample that you were going to be working with. If you're doing a chi-square test of association, that probably means that you have taken one sample. So in this case, I'm looking for an association between the smoking habits of parents and the smoking habits of their children. So I'm really probably only taking one sample of kids. Or I could be taking one sample of parents. But we are looking, actually, we're probably taking one sample of students, okay? So even though I've taken one sample, I'm going to be looking at two different variables based on that one student. So when I talk to a student, I'm going to be asking them two questions. First question is, do you smoke? The second question would be, do your parents smoke? And those results could be that both of their parents smoke, only one of their parents smokes, or neither of their parents smoke. So one sample, but we're asking each person in the sample two different questions, and we're trying to see if we can find an association between the two things that we are asking them about. Okay, so we are going to enter the categories as variables and counts for parent behavior underneath each cell. So for C2, I'm going to leave that first box blank. I'm going to set it up exactly like this table is set up. Before I say that, let me back up. Make sure that you have already provided a paragraph overviewing your question of interest, why you chose it, why are you even interested in this, and describe in detail how you made sure that your sample was random. And you've got videos that you should have already watched to help you with that. Okay, so I'm going to leave the C1 blank. Under C2, I'm going to label that as both parents. And for C3, only one parent. And for C4, neither parent smokes. And then I'm going to see if there's an association between category 1, which is going to be that the student does smoke, and category 2, which is that the student does not smoke. Okay, and then these are just counts. They're not averages, they're not percentages. This is just the number of students that smoke and at the same time both of their parents smoke. So I had 400 in that category. I had 1,380 students that did not smoke, even though both of their parents smoked. I had 416 students that smoked when one of their parents smoked, and I had 1,823 students who did not smoke, even though one of their parents smoked. And then for neither, I had 188 who smoked, even though their parents did not, and I had 1,168 who did not smoke, and neither did their parents. Okay, so the first thing that we want to do is just summarize the statistics to see what is this showing me just in general. So we're going to create a graph to represent our data, and we're going to come up here to the top and click on graph and then choose bar chart. We're going to choose in the drop-down menu values from a table, step number 2, and choose the two-way cluster. You have a single cluster here. You have a two-way table cluster at the bottom. We're going to choose the two-way cluster, and we're going to click OK from that. Okay. In the, let me put OK in that while I'm thinking about it. All right, then we're going to click in the white box for graph variables. We're going to highlight all of the columns over here on the left, and then we're going to hit select at the bottom. So that's going to put all of the columns into our graph. Then you're going to click in the white box that's called row labels, and we're going to highlight C1, which is where our row labels were in our table, and click select so that it pops over here in the box, and then click OK. So your chart graphs, when both parents smoke, this is what we had for our results for students. When one parent smokes, this was our result for students. And when neither parent smoked, this is what our result was for students. So hang on a sec. Okay, sorry about that. All right, so step 5, it says the table arrangement, your columns are outermost. So you'll see that what you labeled as your columns, you're both parents, you're one parent, you're neither parent, that's your outermost label. And then whatever it is you're zoning in on, what you're focusing on, that is going to be what your bars are representing. So the reason I encourage MiniTab use is because all of this is done for you, and it's very easily transferred into your Word document. You can also do graphs in the calculator. However, you would still have to transfer that to your report somehow or to your presentation somehow. You'd either have to draw that yourself, or you would still have to type it into some type of Excel program. So because MiniTab is like Excel, I just do it in here because I can right click right here in the gray area of this graph, and you'll see that I have options to send that graph to Microsoft Word. I could send it to Microsoft PowerPoint. I've never tried to copy and paste the graph into anything. You could do that into a Google Doc, I'm not sure. I just send the graph to Microsoft Word. It pops it right into my report for me. I can click and drag it anywhere that I want it to be if it doesn't pop into the right spot that I want it. So that's done for me. Now, you'll also notice that below each section, after you get through with the steps of making the graph, I have included for you in a double star paragraph, what should you talk about from this graph? What should you include in your report? What should you discuss in your presentation when you're looking at this graph? And what we want to do is we want to see the comparison of our variables. Is the distribution for parents the same as the distribution for students? And what will you try to prove? So if you're looking at these, it looks like I have a difference between all the groups. Obviously, we're looking at counts. We had a lot more students that did not smoke when their both parents smoked. We had a lot more students. We just have a lot more students that don't smoke all the way around. So does it really even have anything to do with parents? Or are we just more educated now? What's going on here? Okay. So what I'm going to do is I'm going to look for an association between these two variables. And to do that, and this is what I'm going to try to prove, since I'm trying to prove there's an association, my null hypothesis would be that there is no association between parent and student habits of smoking. All right, so what I'm going to try to prove, my alternative hypothesis, is that there is an association between them. Okay, and in order to do this, in order to show this association, I'm going to have to check some conditions to make sure that I can even do this test. So number one condition that I have to meet is that it does have to be random, and that should have already been taken care of in your introduction and how you selected your sample. Your large counts have to be greater than or equal to 5. For this test, you do not have to calculate those yourself. Once you run the test later, you'll be able to verify those because it's going to do those for you. Obviously, if they're not met later, we may have to redo the test, but if your sample size is the right size, you should be okay. Your independence condition, sample size needs to be greater than 10. my sample size times 10 needs to be less than the population. So in this case, my sample size of students, I don't have that calculated, but if I, what is that, 1780, if I just get a total of all the students and multiplied it by 10, that should be less than the entire population. So whatever I get out of that, I'm certainly going to have more people than that. You just need to test that, that problem right there, okay? If your conditions are not met, then you do need to adjust your sample size until it works so that you get good results. If your conditions are met, then you just want to put in your report that you've met them, list out what they were, and then you can proceed with your test. So to run the test in MiniTab, I'm going to go ahead and X out of this graph since I've already transferred it to my report. You're going to go up here to the top and click Stat. You're going to go to Tables, and you're going to choose a chi-square test for association. Step number 3, from the pull-down table, you're going to choose Summarized Data in a two-way table. And for step 4, you're going to click in the columns containing the table box. You're going to come over here to the left-hand side and highlight all of those columns, and then hit Select under the box. In step 5, you're going to click in the box labeled Rows. You're going to highlight the C1 variable, and then you are going to check I think you got to hit statistics first. Hang on, let me hit OK. Let's see, rows, highlight C1. Why did that not stick? Hit select. And then I'm going to go to statistics. Yes. Let me add that. All right, so go to the statistics button. I put that in the wrong spot. Sorry. Okay, make sure your chi-square test is checked. We want to make sure display count in each cell is checked. We want to display marginal counts. We want expected cell counts, and we want each cell contribution to chi-squared. So I'm going to add that check to it. Then we can click OK and click OK, and we're going to get our report. So right here, you want to, you'll see at the bottom you have a key. So the first number in each little box is the cell content, the count. The second one is the expected count. So my expected counts are 332, 418, 253. All these second numbers are much, much greater than 5. So now I am assured that that second condition has checked out. And the third one is the contribution to chi-squared, which we'll look at in just a second. Okay. So you want to fill in those expected counts into that condition check that you did earlier, just so you can verify all of those. And then this is what you need to talk about in your report and your presentation. So our null hypothesis was that there was no association between those habits, and our alternative was that there is an association. I'm just going to paste that right here. Okay, and now that we've run the report, we should be able to see if we have evidence that there is an association. So your conclusion is going to be linked to your p-value. Your p-value, if you scroll down, down here at the bottom, you have 2. They're both 0. But you're going to look at the Pearson p-value, which is 0. So my statement needs to start with the p-value is equal to 0. All right. And the p-value equaling 0 is going to be compared to an alpha level. Typically, we compare it to an alpha level of 0.05. That's our standard. What that means is we're working with a 95% confidence level, because 95% and this 5% give me the total 100%. And since 0 is less than 0.05, we're going to reject the null and say that we do have evidence of the alternative. So I reject the null hypothesis, say I do have evidence of the alternative, and the alternative was that there is an association. So I do have evidence of an association between parent and student smoking habits. Okay. If your p-value was greater than 0.05, then you would fail to reject the null hypothesis, which means you do not have evidence of the alternative. If you do have evidence, this is when we're going to look at the contributions. So that second starred paragraph, if it shows a difference, if it shows, I guess a better word there would be if it shows an association, then we want to talk about where we see the biggest differences using those contributions from the test. So your contributions were the very last number, and you'll notice that the biggest one was in this 16.8. I'm not sure how accurate this study is, but it looks like students who smoked when neither parent smoked was a little bit bigger than everything else. Also, 13 was really big, so if both parents smoked, students seem to be smoking more. You want to talk about where you see those biggest differences. Now, your final paragraph after you finished all that, you're going to be explaining what types of errors you can make. You're also going to be looking at the changes in alpha level. These are going to be in separate videos, so make sure before you wrap this up that you have watched the video for types of errors, as well as the video for changes in the alpha level. Now, if you want to use your calculator, that's fine. Your calculator will do a chi-square test of independence, and I'll run through that really quick for you. You have to use matrices for this, and matrix is right here in blue above the inverse key. So if you hit second and then x to the -1, it pulls up a matrix menu. It doesn't matter what's in here because we're going to type over it. I'm going to choose number 1. Excuse me, let me go back. Second matrix, we want to edit this matrix. So I'm going to right arrow over to edit and then choose number 1. And it's going to probably have a matrix already in there, but we want to set this matrix up to be what we want it to be. And what we have in our matrix is 2 rows and 3 columns. So this would be a 2 enter by 3 enter matrix. If you enter 3 by 2, you're going to see that it's backwards. You can just go back and type right back over it, and it'll flip it to the number of rows and the number of columns that you need. So then you just go across the top row, 400, enter, 416, enter, 188, enter. Then it'll take you to the second row, which is 1380, enter, 1823, enter, and 1168, enter, and we have our matrix. To do the test, you would go to Stat. You would use your right arrow key to highlight the Test menu, and you would scroll down. There is not a chi-square test for association. It's just going to simply be chi-squared test. It's letter C. When you hit enter, it's going to ask you for some information. You put all of your observed counts into matrix A, so that should already be there. We did not enter expected counts, but your calculator is automatically going to put them into matrix B for you. So you can leave that alone, and you're just going to come down here and calculate. And you're going to get the same thing you got from your MiniTab output. So my p-value looks like 6.95, but I know it's a probability, so it can't be greater than 1. But I have this e to the -9 at the back, which is scientific notation for times 10 to the -9th power. So we're going to move that decimal 9 places to the left, and that's going to be really, really close to 0. So that is this p-value of 0 right here. You'll use that p-value to make the same conclusion that you made from the p-value with MiniTab. Your contributions to chi-squared, you're just going to have to go look for them where MiniTab puts them right out in front of you. The calculator has stored them in matrix B, so you would have to go back to second matrix and then just pull up number 2, and then it'll pull up matrix B for you. If you hit enter, it'll show you what was inside of matrix B. You'll notice that these numbers match the numbers in MiniTab. You would have to hit the right arrow key to scroll over and see that last column. Now again, calculator will do it, but you're going to have to transfer all that into your report yourself. So MiniTab I think is better, but if you have any questions for me, let me know. Those of you in Danville, if you have any questions, just see one of your math teachers. Good luck.